Good afternoon and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Sandra Jones and we are kicking off 2026 with a series of spacewalks outside the International Space Station. Here to discuss today's spacewalks, we have three briefers. They are Bill Spetch, the Operations Integration Manager for the International Space Station, Deanna Trujillo, who is a Flight Director, as well as Heidi Brewer, who is a Flight Director as well. We'll start with some brief opening remarks from our briefers before jumping into questions here in the room, on the phone bridge, and using the hashtag AskNASA on social media. If you are dialed into our phone bridge, you can press *1 to submit your question. If you do feel that your question has already been asked, simply press *2 to withdraw it. And if you are on social media, you can use the hashtag AskNASA to submit your questions on our various social media platforms. So without further ado, I'll hand it over to Bill for his opening remarks.
All right. Thank you, Sandra. And thank you all for joining us today to discuss these two upcoming spacewalks outside the ISS. These will be the first two spacewalks for Expedition 74, the first of 2026, and the 278th and 279th in support of the International Space Station's assembly, maintenance, and upgrades. The first EVA on Thursday, January 8th, NASA astronauts Mike Fincke and Zena Cardman will exit the station's Quest airlock to finish the prep for the 2A power channel for our future rollout solar arrays, or IROSAs as we call them. Once installed, that array will provide additional power generation for the ISS. Additionally, the duo will swab the outside of the ISS again to test for microbes in our microorganisms experiment campaign. This will be Zena's first spacewalk and Mike's 10th. Mike will become the 6th U.S. astronaut with 10 spacewalks done. And Mike has totaled over 48 hours, over 2 days outside the ISS. On the second EVA on Thursday, January 15th, two NASA astronauts will replace a high-definition camera on camera port 3, install a new planar reflector on the Harmony module's forward port, and relocate a set of ammonia jumpers, which are flexible hose assembly that connects parts of our thermal system, along with some other jumpers on the station's S6 and S4 truss. That fluid system jumper will enable us to refill some of the outboard thermal system ammonia later on. Beyond those spacewalks, we have an incredibly busy start to the new year. As soon as we finish off that EVA on the 15th, we'll move right into another reboost of the space station on January 16th using the SpaceX 33 capsule. This will be the final reboost using that capsule's boost trunk capability. We'll then quickly move into packing up that Dragon in prep for having it undock from ISS on January 21st. Reminder that SpaceX 33 delivered more than 5,000 pounds of supplies and research to ISS. Then there's no rest for us. As we go from that, we'll have to pack up the HTVX vehicle that is also still on board. We will get that packed and targeting unberth and release of that spacecraft in late January. Right now we're targeting January 27th for the unberth and January 28th for the release. The reason there's a split there is there's some experiments that we're doing with the actual HTVX, looking at those sensors and looking at the reflectors on the front of the station to support a future demonstration that they want to do with the HTVX vehicle. HTVX arrived carrying 4.4 tons of supplies and research to the ISS. And then we're looking forward to the launch of NASA's SpaceX Crew 12 in February. That'll send astronauts Jessica Meir, Jack Hathaway to the station, along with ESA astronaut Sophie Ardno and Roscosmos cosmonaut Andrei Fadeev. This will be the second flight for both Jessica and Andrei, and Sophie and Jack's first flights each. The launch is targeted for February 15th today. We continue to celebrate, as we go here, the International Space Station's 25 years of continuous human presence. We're advancing scientific knowledge and demonstrating new technologies that enable us to prepare for human exploration of the moon as we prepare for Mars. Station's design requires humans living on board to maintain, operate, and upgrade it. So these commercial crew missions that come up, as we talked about with that, are very important to the mission. As you can see, we have to do some maintenance outside too, so we'll be going out and doing some spacewalks. given the proximity of the holidays, I want to send a special thank you to the entire team that supported the development work associated with these spacewalks, all the preparation work that has gone into it, as much of that occurred over the holiday season, and the team's dedication always amazes me, and we are ready to go for these upcoming spacewalks. For more details, I'll hand it over to our flight directors. For the first EVA, Deanna.
Great, thank you, Bill. Today I'm going to talk to you guys about EVA 94. As Bill just said, we are very grateful and very excited to be doing this EVA, and grateful to the team who has been working so hard to get us to this stage through the holidays. We will start with the team, so if we could please go ahead and cue up the slide. Okay, our first slide will be the team, as you can see it here. We got Farouk will be our EVA a flight controller lead. At the same time, we have two of our astronauts. The first astronaut going out, which is with the red stripes, is Mike, just as Bill mentioned. And then Zena will be our second astronaut. If we can please go ahead and, perfect, thank you. So there he goes, you got the pictures of them. Let's go for the next slide, please. And the next slide, please. Okay, so to talk about really what we're going to do here, if you can cue the next one as well. Excellent, thank you. All right, so if we look at the station itself and we take a giant step back, the location where we're gonna go do these activities today, actually on January 8th, is on the 2 Alpha area, which is the port side of the space station. So we're gonna come out of the airlock and we're gonna translate to the 2 Alpha port side of the station, where we will go over a few items. One of them is our primary activities, the modification kit, which, as Bill mentioned, is a structure that's going to be holding the solar arrays themselves. We will also have, perfect, that's a slide where you can see the modification kit. What we're going to do with the modification kit here is we're going to put 3 of the struts, the color struts that you see, the blue, the red, and the green one. As we are assembling that, it will take us about 4 hours and a half to complete that activity in a nominal case. And then after that, one of our astronauts, in this case Mike, will move to another activity, which it will be a jumper cable activity. The jumper cable activity will be an installation that we're going to have to increase our redundancy on our power system. In addition to that, that's great, that's a good image. So as you can see on the right side of the station, there's a few activities that are listed there. 2 Alpha mud kit on the right side of the image, then you will see the DDCU cable, which is the second ellipse in the image, and then after that, you'll see that Zena will be also working in parallel to Mike on the torque resets. What that means really is that Zena is going to go to the boxes that you see in here on the bigger ellipse. She's going to undo the torque of a few boxes that we have in there, which are our battery boxes, and then redo the torque at a lower value. The intent there with that is to position us or put us into an advantaged position so that in the future, if needed, robotic operations can come in and remove the boxes. By her changing the torque value, it will enable those operations. Once we complete everything in the port side, what we're going to do then is to now return to the airlock. At the airlock itself, we will be doing 5 samples of the microorganisms. So let's go over that. Thanks for putting that up. For the microorganisms, just like Bill mentioned, we will be swabbing 5 different locations, all of them at the airlock area. The first image that you see on the right of the slide from me is a swabbing right at the edge of the airlock door, the hatch itself. Then we're also going to do a swab on the cover of the hatch itself as well, and then we're going to swab as well the glove. Those are 3 samples that I'm showing you there, but we're going to double some of them, which is why it accounts up to 5. After we complete that activity, Zena and Mike will return back into the airlock, and EVA 94 will have been completed. Now we're going to play a video for you all so you can see all the activities that I just described from end to end. If we can please cue it up. We will begin the day with our crew members Mike and Zena egressing the airlock with their strut bag and the cable bag. Both crew members will translate to the port side of the station, where most of the EVA work sites are located for the day. The crew will begin with the installation of the modification kit or mod kit, which consists of 3 struts and several bolts on each side of the BGA. Once the mud kit is completed, Mike will proceed to installing a jumper cable between 2 sets of direct current converter units to provide additional redundancy on the system. In parallel to that activity, Zena will translate to the port solar array and take pictures of the race ring to capture its current state. Once that is completed, Zena will translate back, where she will torque 3 battery units to a lower value to enable future robotic removal operations. To conclude our EVA, both crew members will translate back to the airlock, and right before they ingress, Zena will collect 5 samples of the nearby surfaces in support of the microorganisms activity. Following that, Zena and Mike will finally ingress the station. And this will conclude our EVA number 94. Okay, excellent, Sandra. That will be it for EVA 94, and now we'll pass it on to Heidi Brewer for EVA 95.
All right, good afternoon, everyone. I'm here to talk about EVA 95, which will be performed on the 15th. And I'll take the first graphic, please. The crew office is currently working on the assignment for which crew members will be working this EVA. We have a number of different flight controllers that have been working very hard to prepare for the EVA, and I really appreciate their efforts in getting ready. This pictorial shows you the starboard side of the space station, which is the primary area where this EVA will be taking place. You'll see that the green blocks are for our EV2 crew member and the blue blocks are for our EV1 crew member. We do have one that's taking place off of the starboard truss, and that is our primary, most important objective for this EVA. That's the Node 2 forward IDA planar reflector removal and replacement. That's all the way in the front corner. You can see in this pictorial a little bit closer, the EVA crew member will be next to the SpaceX 33 Dragon and performing a removal and replacement of the reflector that is at the Node 2 forward location. This is similar to a task that Sunny Williams performed on EVA 91 a year ago. And I'll take the next chart, please. This picture shows you what the reflector looks like. We've got 3 bolts that the crew member will be first using to remove the existing reflector, and then ultimately putting a new one in place and installing a new one for future visiting vehicles. Moving on to our additional activities for this EVA, we have thermal jumper relocation and power jumper installations. For the thermal jumper relocation, you can see the image at the bottom shows 3 different relocations of jumpers for jumpers that will be installed for upcoming EVA tasks. And this, as Bill mentioned, is in support of performing a refill of the photovoltaic thermal control system 1 Bravo radiator. That will be taking place at a future EVA, TBD on timeline for that. And then the images, the top left and right are showing the 2 power jumpers that will be installed at the S4 and S6 locations. Very similar to the task that Deanna explained in her EVA, this will be providing additional power redundancy for our primary power system by connecting DC to DC converter units together in order to provide additional power support. And then this additional pictorial shows the alpha magnetic spectrometer wake radiator. We'll have a crew member go out to the wake radiator and perform a retorque. If you can see the blue box at the bottom of that image, that shows the area where these fasteners will be retorqued. 46 of them will be retightened in support of additional thermal management for the AMS. And then this image shows our HD camera that is at camera port 3. So that it's the box that is to the rightmost of the image. There's actually a standard definition camera nestled in there, and then the HD camera is the box that's all the way to the right. That's the unit that will be replaced on this EVA for us to have additional HD views coming from the camera port 3 location. And at this time, we're going to bring up the video to show all of these events in sequence.
EVA 95 will begin at the Quest airlock. EV1, noted by red stripes, will egress, followed by EV2. Planned tasks include a planar reflector removal and replacement, external high-definition camera replacement, radiator retorque, and multiple thermal and power jumper tasks. The crew members will be at separate work sites for the start of the EVA, but will end up together for the tasks near the end. EV1 will translate to the robotic arm to set up for the camera port 3 external high-definition camera removal and replacement. This task will enable high-definition views from the camera port 3 location after the completion of the task. Meanwhile, EV2 will begin translating to the Node 2 forward port for the planar reflector removal and replacement. This is the highest priority task for EVA 95. After arriving at the Node 2 forward port, EV2 will set up his equipment or her equipment and take photos of the area. EV2 will then remove the existing planar reflector and install the new one. This task is similar to what NASA astronaut Sunny Williams performed on US EVA 91 at the Node 2 Zenith port. The reflector is held in place with 3 bolts. With the new planar reflector installed, EV2 cleans up the Node 2 forward port work site and heads back toward the airlock. Back over to EV1. Our crew member is now at camera port 3 worksite and is setting up equipment. EV1 will be removing the camera port 3 external high-definition camera and replacing it with a new unit. With the camera replacement complete, EV1 returns to the airlock to stow the old camera. EV1 then translates to the robotic arm to head to the alpha magnetic spectrometer worksite. Back over to EV2. EV2 is retrieving the early ammonia servicer jumper from the Zenith airlock and translating to the S6 worksite. On the way to the early ammonia servicer jumper worksite, EV2 installs a gap spanner at S6. EV2 then performs the early ammonia servicer jumper task. And back over to EV1, who's on the robotic arm, maneuvering to the alpha magnetic spectrometer. EV1 is retorquing 46 bolts on the alpha magnetic spectrometer wake radiator. At the completion of the radiator task, EV1 is maneuvered away from the alpha magnetic spectrometer to perform robotic arm cleanup before meeting EV2 on the starboard truss for upcoming thermal and power jumper tasks. Back to EV2. With the early ammonia servicer jumper task complete, EV2 moves along to perform the S6 DC to DC converter unit jumper install. This task will increase primary power system fault tolerance. And with EV1, EV1 is now translating outboard to the S5, S6 truss. EV1 is now at the S5, S6 truss location, performing the installation of the S5, S6 photovoltaic thermal control system jumper relocate. And similarly, EV2 is now at the S4, S5 location, performing the installation of the S4, S5 photovoltaic thermal control system jumper relocate. These jumper relocations are in preparation for a future EVA task to perform a refill of the photovoltaic thermal control system 1 Bravo radiator. EV1 then heads for the last planned task, the S4 DC to DC converter unit jumper install. Similar to EV2's S6 power jumper install, this task at S4 will increase the primary power system fault tolerance. With the planned tasks complete, EV1 and EV2 now translate back to the Quest airlock for a successful completion of EVA 95.
And thank you to our briefers for those opening remarks. We will go ahead and jump into questions at this point. We'll have questions on our phone bridge. As a reminder, please press *1 to submit your question. Once your name is called, you can state your name, affiliation, and to whom you'd like to direct your question. We'll also be taking questions here in the room and using the hashtag AskNASA on social media. So starting off here in the room, go ahead, Mark.
Oh, thank you very much. Mark Carreau with Aviation Week and Space Technology. If I'm sort of recalling this right, there's a 7th and 8th total IROSAs that you want to install. So my question is, when will they launch either separately or together? And when would you like to be able to sort of finish up with both of these additional installations? And I might have a backup question.
All right. Yeah, we are. So we are looking for later this year to launch the 2 new IROSA solar arrays. So we have this mod kit to complete, and then we have one more to do. So we're looking for a time maybe in the spring, but we're not exactly sure yet where that's going to fit to finish the last mod kit. It is on orbit already, waiting to be installed. We just have to go out there and install it. And then we'll bring up the 2 remaining IROSAs together. They fly in a configuration that stacks the 2 of them together on one Dragon in one Dragon trunk. So we'll look to do that later on this year.
Go ahead, Mark.
Yeah, I noticed in some of the backup information, you've mentioned that these will augment solar power for research as the space station winds down as currently planned. But you've also mentioned that it will contribute to the deorbit operations, and I wonder if you might be able to explain a little bit about how that additional energy is needed for that.
Yeah, sure. So obviously, the solar arrays that we have, the original solar arrays that we've flown with the space station have been up there a very long time, and their production just degrades over time, just like terrestrial solar cells will. These have held up really, really well. Now, adding the additional IROSAs to these last two channels helps improve the power generation on those particular channels. So we have a channelized architecture on the ISS, so it'll help us with balancing how we can load the station up across the board. That helps maximize the research that we can get out of ISS as we go forward towards the end. Now, how it helps us from a deorbit standpoint, as we get lower and lower in the atmosphere, as we get closer to deorbit, we'll have to park our solar arrays. So we have to position them, because when they're rotating, as you get lower and lower, the atmospheric drag grows, and so it becomes a controllability concern that we have to go address. And so, but to do that, we basically fix the solar arrays in one spot, and that way we've isolated that variable. We don't have to worry about it anymore, and we can control the stack much easier in the time frame where I'm not doing research. But I still have to maintain the core loads on the station. So you can imagine when my arrays are parked in one position, they're not generating as much power. And so the extra energy that we can get out of specifically these two arrays really help us on those last two remaining channels to maintain that balance and put us in the best posture to control all the critical systems still when we get to the final deorbit. So it helps us today with our research, and then at the end again.
And our next question will be from Gina Sensuri.
Gina Sensuri, CBS News. What makes it advantageous to swap for microbes at the airlock? Is it just like last thing you do before you go inside?
Yeah, that's a good question. So from the scientific standpoint, there were several locations that the team was interested in doing. What they wanted to do was at the airlock. I couldn't tell you more about the scientific output of that, but all of them were located there as we were exiting and coming back in. That is as much as I can tell you about it.
Previously, we had sampled some other vent locations. They're looking for locations that are nearby where we have traffic and atmosphere leaving the ISS and looking in those areas.
Thank you. We'll take a question on our phone bridge from Will Robinson-Smith.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you for taking the time to talk with us today. In regard to the final station boost that the Dragon from CRS-33 will perform later this month that Bill mentioned, is the timing of that in relation to the delayed launch of the Progress vehicle because of the issues at the pad there? And how does that delayed launch of Progress impact the station schedule and further reboosts? Thanks.
No, that's a great question. Actually, this reboost has been planned for a long time, even before we had the issues at the launch pad in Baikonur. So that is not an impact to this. We had always tried to maximize the use out of this Dragon boost trunk to allow the Progress vehicles that show up to deposit their propellant into the tanks on board and really rebuild the amount of propellant that we have on board. As you probably remember, we've just gone through the solar maximum here, which is where we have to use the most propellant for altitude maintenance on ISS. And so the SpaceX 33 boost trunk allows us to recover that propellant quickly. The delay in the Russian Progress, again, it'll all come back to the final numbers of how many that get delivered. We're working very closely with our Roscosmos partners to go work through exactly what that looks like.
Thank you, Bill. Our next question is from Bill Harwood with CBS News. If you're talking, we're not able to hear you.
Well, I'd have to unmute, wouldn't I? There you go. Bill Harwood, CBS. Two quick questions for me. The retro reflector that's being swapped out, is there something wrong with it? I mean, has it got thruster residue on it or something that's making it less efficient? And second, and this is following Mark Carreau's question, looking ahead to ISS deorbit, is any of the work on both of these EVAs, any of the power or thermal jumpers, et cetera, does any of that have anything to do with ISS deorbit, or is this all work you would have done anyway? Thanks.
Two great questions. So, as with the previous reflector that we replaced, this one is also seeing some amount of degradation in the amount of return that you get from the sensor. So it's an optical reflector. So we have seen some degradation on it. It's not to the point where it's not working, but you've had to basically boost the power on the systems that use it to about their maximum to get out of it. So now's the time to go replace it. It just happens over time as you build up, whether it be from UV, there are materials that get deposited from spacecraft coming and going, like you said, thruster products, potentially other off-gassing products that just come from spacecraft as they come up and dock to the ISS. This is right close to a docking port, so you can imagine it gets the full brunt of anything that off-gasses off of a vehicle, and that just builds up over time. On the EVA work, we talked about the IROSAs have a lot of utility for us, both in our nominal operations and for deorbit. The jumpers that we're doing have been get-ahead tasks for a long time. They add redundancy to our system so that we can recover activities quicker across our primary power system. Each channel is kind of separate in how it operates, and these allow us to cross-tie some of the systems within those channels to keep them operating in case of failure cases. It's obviously more desired in a case where, once I get to the point where the ISS has been decrewed for the final deorbit, but it still helps us out today.
Thank you. And as a reminder, you can submit your question using *1, but we will jump over and take a question from social media. This comes from Instagram, and the user wants to know, what do the astronauts do about food or water during a spacewalk?
That's a great question. I will tell you that for EVA 94, the same for 95, and I'll look forward to what Heidi has to add, is for water itself, we go out with a bladder also inside where the crew members can actually sip water. So that will be with respect to it. For food, obviously, we are not able to actually provide food to the crew members themselves. However, as we're leading to the EVA, that is something that we keep in mind. They're certainly taking their meals before we are actually starting the prep to getting into the airlock where they fit their suit and start pressurizing to get out. But it's a great question because it's several hours. For example, on my case, my EVA, the max number of time that we go on the EVA is 6.5 hours. So during that whole time, we are only talking about water. And of course, when they come back, I'm sure they have their own meal and they have fun celebrating the end of their EVA. Heidi, would you like to add anything to it?
Yes, one additional comment on that. The crew members do have a chance to practice this type of routine in the neutral buoyancy lab prior to flying. And so they are accustomed to this type of I guess, being without snacks, but having the water available to them. And they also are accustomed to working very hard for that duration and knowing when to take breaks and how to communicate with the ground so that we know that it's time to take a break so they can charge up and get ready for the next task. So the crew members are certainly ready for this and excited about it. And it's always fun to hear their stories once they're finished.
Thank you. And we do have another social media question. This user on X wants to know, how does the crew train and prepare for spacewalks?
I will start with that for EVA 94. It's a great question again. So Heidi just mentioned it, right? So one of the things that we do for the EVAs themselves is we train in the neutral buoyancy facility where there is this big giant pool that has the mock-up of the space station. The crew members will suit up, get into the pool and practice the activities that we're going to do. Sometimes we practice activities that are generic so that you can get the hang of the feel of the suit and the activities in general. And in our specific case, when the EVA gets assigned, then now we practice the actual activity that we're going to do with different crew members also, so we can see it from different angles and include the fact that we're talking about different humans and different instances. So that's one aspect of it. The other aspect is if the crew members get assigned the EVA and they're already in space and we actually haven't done the preparation with the pool itself, with that specific or that pair of individuals, then we also add to their training by sending them all the material scenario by sitting down with them and doing the training together, walking them through the task. We uplink all of the procedures, the videos, and so as a team, from the ground on space, we work together to make sure that we understand what the coordinated motions are going to be for the EVA. In addition to that, we also do training with the tools, for example. So the crew members pack their own tools, and you start getting the feel for how the tools themselves are going to behave and what the feel is of the tool itself when you're doing the activity. For the 2 Alpha Mudkit, and I'm sure Heidi had also her familiarization activities, for us, we took the struts for the Mudkit that I mentioned earlier, and we did a pre-build of those struts so that the crew member will understand how much force you're putting in, how does it come together, and what the expectation is as it goes.
For EVA 95, we do have a special connector that's never been manipulated on EVA before, but has been in IVA. And so we've had some practice for the crew to get a chance to feel for what it's like with the glove on, to understand what it will be like when they're performing the task. Also want to mention that we've set up conferences. So for example, I mentioned that the Node 2 forward planar reflector removal and replacement is similar to a task that Sunny Williams performed. So we're able to set up conferences between crew members and have them share experiences so that they can share lessons learned and be ready for what might be coming their way, things to watch out for, and those types of things.
Great. Our next question is a follow-up from Will Robinson-Smith with Spaceflight Now.
Hey, thanks for allowing for a follow-up. Question to Bill again. Can you provide an update on the status of the health of the spacesuits, how they're doing right now, and their ability to perform as necessary for the remaining life of the station, and if there's any plan for the currently in development Axiom suits to be used on a later date for a future spacewalk before station retirement? Thanks.
No, it's a great question. The suit fleet, we continuously monitor it, and we continuously work to refurbish the suits. As you know, we have 4 on orbit today. We try to maintain 4 on orbit, but we cycle through them, and so they come down and they get refurbished and they get sent back up again. And so then we do a lot of maintenance on board to check the health of the suits. The suits that we have going out the door are in great shape. Everything that we have on board looks really good. We conduct a large review before EVA, looking back at the history of those suits, any performance that we've seen in any of the maintenance activities, and so we continuously check that. As well as the teams here on the ground are always working the logistics of all the different parts that we need for the spacesuits. So we're continuing watching that and working through it all the way to the end. Right now, there's no plans for an Axiom suit to go do an EVA on ISS, but we'll see what the future brings. But today, we've got the suits that we've got, and we're working through the rest of ISS with those, and we have a great plan to kind of keep those up and running and monitor the health as we go.
Thank you. And it does appear that those are all the questions that we have received today. So our coverage of Thursday's Spacewalk will begin at 6:30 a.m. Eastern. You can watch on NASA Plus, Amazon, and YouTube. We do hope that you'll tune in and follow along for this Spacewalk. But for today, that will do it for us here at Johnson. Thank you.